we've got, looks like this is leaking out a bit. Okay, I've got two balloons here. This one has air in it, this one has helium in it. The helium balloon doesn't float because the weight of the balloon itself is a little bit too much. Okay, now why does it shrink? Well, we know ideal gas law, PV equals nRT. The pressure is staying pretty close to an atmosphere. So if the temperature goes down, the volume is going to go down. And in fact, we can predict how much the volume goes down because it's going to be the ratio of the old temperature to the new temperature. I said that backwards. So the new temperature to the old temperature, the new temperature, well, it's going to be about 77 degrees Kelvin because that's the temperature of liquid nitrogen. The old temperature was about 300 Kelvin. So that's about a factor of 4 to 1 in temperature change. So the volume change will be also about a factor of 4 to 1. So I think this is probably shrunk down pretty much all the way that it's going to. So as I pull this out, see if you agree that this is approximately 4 to 1 change in volume. It warms up again quite rapidly, so then you'll see the balloon expand again. Okay, so there we go. So was that about a quarter of what the original volume was?
Yep.
Yeah, about. So we're close there. And now the gas is warming up and expanding to fill the rest of the balloon.
Can you nail the balloon?
Okay, I'm not going to try to nail the balloon anymore. Okay, what about the air-filled balloon?
That's crazy.
Well, does air obey the ideal gas law?
Yes.
The answer is it sort of does. It does. When do gases obey the ideal gas law? We talked about this last time. When they are far from the condensing point. Okay, what's the condensing point of air? Where'd the balloon go? Okay, the condensing point of air, well, the condensing point of nitrogen is 77 degrees Kelvin. That's what it is right now, right? So if I put nitrogen, which is what the air mostly is, into liquid nitrogen, it turns into liquid. And this doesn't obey the ideal gas law. Oxygen, it turns out, condenses, I think, a little bit higher than nitrogen even, so the oxygen turns into liquid too. So this balloon here now is actually filled with liquid, not with gas anymore. So the correct answer was A, not B. And you can see what a liquid-filled balloon looks like. Here. And so if you come up here, you can actually see a little tiny bit of liquid. It's expanding again.
That is
the nitrogen in the air turning into gas.
That is way cool.